Okay, so today we're going to be talking about 2.4. I want to wrap up a couple topics though because I had a couple questions about min and max, and I wanted to give you an example of the focus and directrix. So the min and max, we didn't talk about it specifically in any of the lectures, but I'm just going to go ahead and just kind of really quickly explain what min and max are. So if you have, and I'm just going to sketch here, an upward facing parabola, okay? The upward facing parabola is basically the domain is all of x, okay, because these arrows are going to continue to go on forever. The range, however, is from this point right here, which is the vertex, HK, and everything above that. The parabola does not live below a certain level on the y-axis. In this case, it's k, okay? And so the vertex, which is h and k, in a upward facing parabola basically has a min, okay? And likewise, if you have a downward facing parabola, okay, it has the opposite concept in the sense that these two arrows continue the parabola down forever. So again, the domain would be all of x, but for the range, there's a point where it hits right here, okay, the vertex, and the parabola no longer lives above whatever that y value is. So if this vertex is h and k, all right, then this vertex also is known as the max, okay? So hopefully that helps a little bit with the max and min problems. The other thing I wanted to talk about was how to find the focal point, the focus point, and also the directrix of an equation. So what I'm going to do, today we actually had a chance to graph on Desmos the graph of, let me see if I can remember it, y is equal to -1/2 x minus 2 squared minus 4, I think it was, okay? And we ended up with this black graph that was facing down. Okay, I'm just going to draw a really quick sketch of it right here. It was like a graph that was kind of facing down like this, okay, and we were able to see that the focus was, I think it was like 2, 2, okay. So in class I discussed the concept of a focal point, all right. The focal point has, in this case would be, in any case, it would be inside the parabola. I know this is really small and hard to see. So we want to find this point right here, which is the focus, okay? And then on the other side of it, okay, which is, so this vertex right here is equal distance to the focal point as it is to the directrix. We need to find the equation of that directrix line, okay? So not that long ago, you guys took a notes, I think it was 2.3, yesterday maybe? You guys took notes on the general equation of a parabola with respect to a focus and directrix. So I have a downward facing, I had like a chart here with the 4 quadrants. The first 2 were talking about a vertex that was at the origin, and the other 2 was talking about how to get the focal point or the focus where it wasn't in the origin. Well, in this case, this parabola is not in the origin, okay? So the vertex is not in the origin. So we're going to have to consider the h and the k that's part of this, okay? It is a downward facing parabola. And so if we look at our notes, we can use the vertical, we know there's a vertical axis of symmetry at h and k, and this is the case that's not at the origin. So the note that we had yesterday says that a parabola in this context will have the equation 1 over 4p, okay, times x minus h squared plus k. Now, we found in class that the focus is at 2 and 4, okay? You can pull that out just from getting the equation, all right? But what we really need to find is we really need to find this p right here, because that will help us, and this is -1/2. So this will help us find the focus. So if I'm going to highlight this with a different color, okay, you can see that this is my h, this is my k, but we might have to do a little bit of algebra to solve for what p is exactly. So in this case, we have -1/2 is equal to 1 over 4p. Now you can cross multiply, do whatever technique you like, okay? And so you're gonna, when you do that, I'm gonna move it to the side. I'm gonna have 4p is equal to -2, so p is equal to -1/2. All right, now if p is equal to -1/2, we know that the focus, I know it's hard to see here, it's going to have the same x-coordinate, all right, as the vertex. So in this case, our vertex has an x-coordinate of 2. All right. However, the thing that's changed is the k value is going to be underneath this. And how much has it changed? By a factor of p. And so to find the y-coordinate in this case, we have to take our k and we have to add it to what we found, which is p. So if we continue this, it's going to be 2, comma, k, which is -4, okay, and it's going to be plus -1/2. So my picture is not quite to scale. So basically the focus is going to be 2, comma, -4 and 1/2. 1/2. All right. Now, if I kind of talk about this a little bit, if the distance between our vertex and our focus is -1/2, then our directrix is going to be 1/2 above it. All right. So if k was -4, then our directrix is going to be -4 minus -1/2, or in this case, +1/2. All right. So then our directrix, so this is going to be, sorry, some side work. This was for our focus. Okay. And I'm going to do a little more side work over here. The directrix is going to be at it's going to be right here. So it's going to be y is equal to -3.5. All right. Okay, moving on. Let me talk a little bit about modeling data. Let me give you a quick example. So there's different situations that you'll have in your homework where they'll give you information. Either they'll give you 3 points, or they'll give you a table of information, and you can either solve it, as with any of our math that we've done, algebraically or graphically. Okay. I tend to do algebraically because it's more accurate. But let's just go ahead and say we are given an example where we are given 3 points on a parabola. Okay, this is the last example I'm going to outline for you. Okay, so we have 3 points on a parabola. Okay, and they are -1, 4, 0, 1, and 2, 7. Okay, and we have to find the equation, or I'll just say find the quadratic equation or function that represents this parabola. Okay, so we know we have a parabola that has 3 points on it. We need to find an equation for this parabola. So let's just go ahead and start with the standard form. Okay, so I'm going to say consider standard form. Why? Because we can put all 3 of these points into a standard form. This is our y, this is our x-coordinate, this is our y. Here's our x-coordinate, a y, x-coordinate, and a y. So let's go ahead and use the first point right here. All right? If I have a point, -1, 4, and I put in the values into a standard form quadratic, I get 4 is equal to a times x squared plus b times x negative what? Plus c. This is an equation that represents the information for the first point that we have. Then let's go ahead and consider the second point we have right here in the red. Our y is 1 is equal to a times 0 squared plus b times 0 plus c. Then the third point that we have, let's see if this one works, is this one right here, 2 and 7. If we plug that into a standard form equation, we have f of x, or y, which is 7, is equal to a times x, which is 2 squared, plus b times 2 plus c. And so suddenly we have to stop for a second and we see that we have a system of equations, 3 equations and 3 variables, and that should tell you that you can use some kind of a strategy to solve the system for a, b, and c. So elimination, graphing, or substitution, see if you can figure it out.